All right, in this problem they asked us to solve polynomial function. And I'm going to count the number of terms. Count with me. Ready, set, go. Okay, it has 5, so we can't factor by grouping. We're going to have to. How are we going to have a starting point? We can use the rational roots theorem. You're going to take your last and your first. That's our Q. So P divided by Q. And you're only taking the 12 because it's going to be plus or minus anyways. So what are the factors of 12? 1, 12, 2, 6, 3, and 4. And then the factors of Q are just 1. And all of these are plus or minus. Where do you guys want to start? Pick a number. Let's start with the smallest number. Let's start with 1. So I have the coefficients 1, 2, -7, -20, and -12. Bring this down, you get 1. 1 times 1 is 1. 2 plus 1 is 3. Multiply, add, multiply, add, multiply, and I get -36. Class, what does that mean? By the factor theorem, I have a remainder here, so this means that this is not a factor. Not factor. Okay? What's another number we can test? Let's try -1. I'll use the same numbers. 1, 2, -7, -20, and -12. Bring it down, I get a 1. Multiply, what do we get? -1. Add. Multiply. Add. Multiply. That's a 20, right? Add. Multiply. Add. 0. It's a good thing because if it has a remainder 0, that means that this is a factor. That means so far, let's not lose this. So far, we have, how would you write this as your binomial? X minus 1 or x plus 1? X plus 1 is a factor, and we still have this now, -12, -8x. So I'm just going in this direction. I know that this is my constant, and you're just going to go up. So this will become x squared, and this will be x cubed, and this is positive. Okay. Now, I have a polynomial with 4 terms. Can you factor by grouping here? No, so you can use the rational roots theorem again. And the great thing about this is you already have the numbers, the same numbers as before, right? 12 and 1. We just need to pick a number. What number do you guys want to pick? How about 3? So now I have 1, 1, -8, -12. 1, 1, -8, and -12. So I pick 3. Let's test it. Bring it down. Multiply. Add. Multiply. Add. Multiply. And you get 0. That means that this is a factor So let's add that to our list. So I already have x plus 1. Class, what binomial does this one become? And what's left? 4x, so this is positive. 4x is positive. And 1 is x squared. And then the last part, all I have to do is factor this last one. So I have a times c is 4. My b value is 4. Two numbers that multiply to be 4 but add to be 2 and 2. So my answer is x plus 1, x minus 3, x plus 2, and x plus 2. And then we can just combine those. We have x plus 1, x minus 3, and x plus 2 squared. Okay. I want to make it very clear what we've done so far. Hopefully, can you see this yellow line coming down the side? All of this in yellow so far. Class, is that factoring or solving? All of this so far has just been factoring. Okay, let's now solve. How do you solve? How do we get x equals, right? That's what it means to solve. Whoops, forgot one right there. We're going to use the zero product rule. You're going to see each of these equal to 0. Now, this one has 2 of them, correct? You could do it twice. You're doing it twice because we already had those 2 binomials there. So here we have x is equal to what? Negative 1, 3. Okay, how do you write negative 2? Twice. You could write negative 2 twice, but we also have a word that starts with an m that's called negative 2 with a multiplicity of 2. Does that make sense? The multiplicity there is twice. It's just saying instead of writing negative 2 2 times, you're just saying multiplicity twice. So here in pink, what do we do here in this area of pink? You are solving, or a fancy word for that is they say find the zeros. Find zeros. Because then you can actually go ahead and actually do a rough sketch of this graph, graphing by multiplicity. So let's review. Polynomial had 5 terms. I can't factor by grouping. I can't use my X box. I used rational roots theorem. I found one of those, and it gave me now 4 terms. I still couldn't factor by grouping, so I used rational roots theorem for these values here. I found that 3 was one of them, and then you can just use your more basic factoring skills. So that was all factoring. And to solve or find the zeros, you're just setting them equal to 0, and you get your values. So our answer is, to solve this equation, my answer is negative 1, 3, and negative 2 with a multiplicity of 2.